All right. Well, hello everyone. This is our project for demo. So we'll start here with the digital clock. And as you can see, we have a lot of different kinds of inputs for the reset, the clock, a set button, also with the seconds, minutes, and hours. One thing I wanted to point your attention to is this snippet right here towards the end. This part is basically ensuring that the clock does not run over a certain number. Obviously, clocks, minutes and seconds cannot go above 59 and hours cannot go above 23 in military time. So basically here, we're making sure that within our always statement, as the clock is running, we make sure that when it reaches that maximum value for seconds, minutes, and hours, it resets itself back to 0 so that the clock can run properly.
Yep. And hello, my name is William Krska. And one of the things I worked on is the VGA driver. And one part that was a nice kind of step forward from last time is the way that we implemented our quote unquote 7-segment digits. So here we have an individual module called VGA digit, where instead of putting all of the different regions that a quote unquote digit exists in, for every single number on the display. Instead, we had 6 instances of it. And in VGA digit, we had an array of, or a number of different, basically conditions for whether to light up or not light up that given pixel for whatever number it is that's being fed in. So in case that would be 0. So this shows you the regions for a 0. This is an A for when we display alarm. Another fun thing is in the decoder. So if we scroll up here in this very large always block, as you can see here, this displays the output based on the display mode. So it's kind of cryptic, but what that means is depending on our display mode, which is either showing the clock, setting the clock time, setting the alarm time, or changing the clock mode from 24 to 12 hours, this will basically determine what numbers are being sent to the display driver. So in the first case, this is for if it's just showing the clock, and we have a condition of if the alarm is sounding, send the signals for the alarm. If the alarm is not sounding, then we either send a 24-hour signal or we hit a modulo on it and send a 12-hour signal. And it's similar for here. Sends our set clock signal, sends our set alarm signal, or here's the same thing, just sends an either 24-hour or 12-hour signal to the display driver.
Welcome to the demo portion of our video. As you can see, we're right now on the second mode, which is where we can set the time. So currently I have it set at 1:21 p.m., 0 seconds. And the next mode right here, this is setting the alarm. So right now we have it set at 1:22 p.m. in 2 seconds. And so once we switch to the next mode, the clock will start counting towards the alarm. And if you press the center button on the FPGA, you can switch between the PM, AM, and 24-hour military time, indicated by the LEDs. Very nice. And so we're about 30 seconds away from the alarm. So we'll switch over to mode 1, which will also show the time. But like I said, give it another 20 seconds. And when the alarm reaches, the VGA display will display alarm. And then we'll wait 15 seconds before it resets back to the original time. So about 5 more seconds.
You see, it switched to that's LED time.
Alarm! Woohoo! Nice.
That's nice.
And so we'll wait for about 15 seconds
Then it's nothing.
before it'll reset to the original time. And now we resume back to the time, and we can always set a new time, always set a new alarm, and we can start again. But I won't do that for the video purposes.
The reason we chose this route to go with the digital clock is that we want to expand on the work that we had done in the previous lab, where we had created a sort of mock 7-segment display using the VGA output. And we thought we could bring that concept a little further, put more digits, but do it in a more efficient way. We also chose to use the buttons the way we did in a sort of D-pad configuration because it seemed intuitive to us. And especially with using a display output like that, we can make a little more sense with the up, increasing numbers, in the right button switching to the next mode where the button or the indicator on screen would actually move to the right. We did run into a couple issues though.
So one of the issues we ran into was hours, minutes, and not rolling over. So for example, if it was 23 hours, 59 minutes, and 59 seconds, theoretically the hours and minutes, seconds should all reset to 0. But for some reason, the hours and minutes would not go to 0; they would stay. So what we had to do was look into the digital clock code, and we realized that the checks for making sure that it goes over to the 0 digit, they were all nested in an if loop, but we had to bring those out into separate individual if statements. And so when we did that and we ran the test again, it worked perfectly.
Yeah, we also had some issues with interfacing between the modules. So we had this confounding issue where if we were to press a button in a certain module, it would increment something appropriately, but ported that same exact program or block of code over to a different module that was wired into it, it wouldn't do it properly. And we found that was down to the way that we had a wire coming off of a register that was read and used as an output in an auxiliary module. And we weren't constantly updating that value. And so as a result, it wouldn't actually update the output of the main module. We also had some issues getting the display to update, and that was kind of tied into that previous issue where it would just stay at 0000. And even though the clock was running in the background, you could change things in the background, the display itself wouldn't change.